Welcome to the video lecture series of Project Development and Resource Management. Course code NC301, contact hour 4 per week, credit 4. Myself, Dr. Shunipa Roy, Assistant Professor of Electronics and Communication Engineering Department, Guru Nanak Institute of Technology. This is the lecture series of Project Development and Resource Management. This is MTech course, MTech third semester. Today we will discuss Module 1. Module 1 consists of meaning of research, objective, motivation, then different types of sample designing, testing of hypothesis, chi-square test, a statistical measure of sampling analysis, then data collection and storing through database management system, concept of data warehouses and data marts, concept of multidimensional analysis of project data, different types of statistical analysis through SQL. This lesson plan particularly depends on different types of sample designing, testing of hypothesis, chi-square test, a statistical measure of sampling analysis. This is lecture 7. So the learning objective is, by the end of this session, you will be able to know, or you will be able to define the developing null and alternate hypothesis, explain hypothesis testing procedure, the critical value of the last test statistics, discuss type 1 error and type 2 error, define the level of significance, define the confidence coefficient, explain the power of a test, explain the p-value approach to hypothesis testing. In our last class, we have studied that we have two types of hypothesis and we have two types of statistics. One is descriptive statistics and another one is inferential statistics. Statistical interference. Statistical interference means drawing a conclusion about a larger population based on a small part of the population. That means what is going to happen in near future, you can collect the data by taking a sample from the sample population. Population is the bulk. So inferences are drawn based on the testing of certain assumptions of hypothesis. Actually, I am trying to predict something. So that is actually statistical inference. We have some reference, we have some statistical data. Hypothesis is a statement made about a population in general. But actually, hypothesis is nothing but a decision. What decision you have taken? Maybe it is wrong or right, but hypothesis is nothing but the taking of a decision. Now, particularly based on the probability distribution or the value of its parameter. The hypothesis particularly based on probability distribution or the values of its parameters. Actually, there are statistical hypothesis, simple hypothesis, and composite hypothesis. Statistical hypothesis Actually, there are two parts. In statistical hypothesis itself, there are two parts, simple hypothesis and composite hypothesis. So what is statistical hypothesis? Any statement or assertion about a statistical population or the values of its parameters. That is actually statistical hypothesis. The simple hypothesis means a statistical hypothesis which specifies the population completely. The probability distribution and all parameters are known. Whereas composite hypothesis, which does not specify the population completely, some probability distribution and parameters remain unknown. So what is the difference between simple hypothesis and composite hypothesis? Simple hypothesis, actually all the data we are having, and we have to draw some conclusion. But in composite hypothesis, there may be a missing of data. Then in that case, we have to so composite hypothesis is quite complicated because we don't have all the data with us. But simple hypothesis, we know standard deviation, we know standard sampling error, all the things we are having. Now we have to draw some conclusion. So the test of hypothesis, which specifies a set of rules for decision making, whether to accept or reject the hypothesis under consideration. That is null hypothesis. So there are two types of hypothesis. One is null hypothesis, another one is alternate hypothesis. So let us see what is null hypothesis and alternate hypothesis. Null hypothesis is generally denoted by H naught. What we assume is true to begin with. Typically that there is no difference, effect, relationship, etc. That means null hypothesis means there is a word no. No cigarette smoking, there will be no cancer in the world. No polio, if you take the polio drops, if your child takes the polio drops regularly. So that is null hypothesis always related to no. That means no social intimation, no COVID pandemic situation. So this is called null hypothesis. Alternate hypothesis is just reverse of null hypothesis. Null hypothesis is denoted by H naught and alternate hypothesis is denoted by HA. Somewhere it is denoted as H1. So alternate hypothesis is just the reverse of null hypothesis. What you are expecting, that no cancer if there is no smoking. So alternate hypothesis is there is cancer if there is no smoking. So this is not true. That is the alternate hypothesis. That means there is cancer when there is no smoking. So this is an example of null hypothesis and alternate hypothesis. That is, no significant difference in average marks of male and female students. This is one of the examples of null hypothesis. And no relationship between age and COVID-19. That is another example of null hypothesis. Here in two examples we can see that no, the term no is appearing. First one is no significant difference. Second one is no relationship between age and COVID-19. So if I go through alternate hypothesis, here are two examples. A significant difference between average marks of male and female students. Just reverse, you follow, you will find that the alternate hypothesis is just reverse of the null hypothesis. A significant difference between average marks of male and female students. Significant relationship between age and COVID-19. Whereas in null hypothesis, we have put that no relationship between age and COVID-19. But in alternate hypothesis, we are declaring that significant relationship between age and COVID-19. So you please remember that null hypothesis and alternate hypothesis is just reverse to one another. So moving to the next slide. Here are some examples of null and alternate hypothesis. See, you can take an example that after 23 years, students are not much interested to continue their study. Rather, they are interested to continue their job. So, this 23 years is the central point. And you may vary it, that is less than 23 years, that means say 21 years, and greater than 23 years, that means 25 years. So in between this range, 21 years to 25 years, this is true that students are not interested to continue their study. Rather, they are much more interested to continue their jobs. So that's null hypothesis, that is mu equals to 23 years, and that is denoted H0 by H0. An alternate hypothesis is just reverse of null hypothesis. That means mu is not equal to 23 years. Mu is the mean or average of the age of student. Mu is not 23 years. Second is null hypothesis, mu is 23 years. Alternate hypothesis, mu is greater than 23 years. That means it may be 25 years. Third line, mu is less than 23 years. So here also, for null hypothesis, you will find mu equal to 23 years. And for alternate hypothesis, you will find that H1 here, if mu is less than 23 years. So first column is the example of null hypothesis, and here the last column is the example of alternate hypothesis. Hope it is clear to everybody. Now hypothesis testing. True state, row is presenting the test result, and column is presenting the test state. So when null hypothesis is true, when H0 equals to true, and H0 in row also H0 equals to true. So what I mean to say that this one and this one, then the decision correct decision. But when H0 true, or similarly H0 false, then this is called type 1 error. So what is type 1 error? Say average age of the student is 23 years, but it may be less than that, that is 21 years. So this 21 to 23 age can fall on type 1 error. Similarly, type 2 error is, say it is above 23 years, say up to 25. So from 23 to 25 years of age, students are keen for their job. So that is type 2 error. So when H0 false, again here column also H0 false, then this is correct decision. But H0 false or H0 true, this will render type 2 error. So if we just reverse the column and row, then we will find the status theta equals to theta naught, that is your null hypothesis. So theta for this is correct. This is type 1 error. And this is alternate hypothesis. This is type 2 error. This is correct. Actual decision is correct decision. So from here we can find two parameters, alpha and beta. So what is alpha? Probability of type 1 error. What is type 1 error? The range of students that fall between 21 to 23 age, that is type 1 error. So alpha is nothing but the probability of type 1 error. Similarly, beta is nothing but the probability of type 2 error. What is type 2 error? The age of the students fall between 23 to 25 years. That is type 2 error. And exactly true value is age is 23 years, where students are keen for their jobs only rather than their study. So this alpha and beta, the probability of type 1 error and type 2 error respectively, the goal is to keep alpha and beta reasonably small. So that means if error is small, then the system is adequate or satisfactory. So moving to the next slide. This is called power of a test or critical region. Here we will find what is critical region. So what is power of a test? Power of a test is nothing but equals to 1 minus probability of type 2 error. So 1 minus probability of type 2 error is nothing but the probability of rejecting H1, that is alternate hypothesis. 1 minus probability of type 2 error, that is equal to probability of rejecting H1, that is probability of rejecting alternate hypothesis. The set of value of the test statistics which lead to rejection of null hypothesis. That is the critical region. So what is critical region? We find it that this is the non-rejection region or critical region, that is supporting null hypothesis. That is, do not reject null hypothesis, rather supporting null hypothesis. What I am telling that, say the age of the student is age of students is 23 years. So what we have taken from 21 to 25, those students who fall in this category, we can take it as 23 years range, and we can take that this range 21 to 25 is accepted. So if you consider this is 21, this is 25, and the middle one is exactly 23, then from 21 to 25, this is our non-rejection region or acceptance region. And this 21 age or 25 age is called critical value. So within this region, we do not reject null hypothesis, but beyond of this region, we reject null hypothesis. Say the age of a student is 26 years. So we can tell that from 21 to 25, we can take it as a granted. But above 25, no, it is not of our use. We can't accept this 26 years data. Maybe 26, maybe 27. So that is the rejection of null hypothesis. So this is 25 and above years. This is 21 and below years. So what is written over there? The set of value of the test statistics which lead to rejection of null hypothesis. That is the critical region. This critical region actually colored as red. This is the critical region, that is rejection region. The set of value of the test statistics which lead to rejection of null hypothesis, not acceptance of null hypothesis. So here we can find this is rejection. And always remember the null hypothesis will cover, that is accepted non-rejection region will cover 95% of the hypothesis, and rest 5% hypothesis will fall in the critical region. So among this 5%, 2.5% will lie in this below region and 2.5% will lie in the above region. So this is for 95% data that can be acceptable. And if you experiment with a large set of data, then this is suggested. Actually, you will find this type of Gaussian type of curve if you work with a large set of data. But if you work with only with 10 data, say, then this will not work. You will not get this bell-shaped curve. So for large set of data, this graph is much more appropriate. So this is the critical region that is in one-tail and two-tail test. So what is one-tail test? Say we are accepting that above 21 years, all students can fall in this category that they are more keen to continue their job rather than continue their study. So only one tail is remaining here in this left hand side. That's why this is called one tail test. Similarly, if we consider that below 25 years, all category of students are more interested to continue their job rather than to continue their studies, then this will be the tail, but this is the upper region tail test. So one tail test can be at the left hand side tail, can be considered as right hand side tail. But two tail test means the region that falls between 21 to 25 years. This is called two tail test, that is beyond 21 years, that is not accepted. Above 25 years, that is also not accepted. So here we have learned one tail and two tails test, and what is critical region, that is 95% of the mean or population has been considered in this no rejection region, that is null hypothesis is accepted in this region. So this is the reading material. If you have any query, feel free to ask me to this email ID. Thank you.